Assalamu alaikum. Assalamu alaikum, Shavi.
Hello?
Assalamu alaikum.
Hello?
Is my voice is clear?
Yeah,
Okay. How are you? Hope you're doing well and everything is fine over there.
yeah, everything's fine.
Okay, so I think this time is suitable for you, not 12 p.m. because
Oh, was it meant to be at 12 p.m.?
yes, because I am
Oh,
waiting
I'm
from
sorry.
12. So
I'm sorry. Didn't mean that.
so is it not convenient for you to take class
It's
at 12?
just I thought that it would have been at 1 again because it was
Okay.
at 1 o'clock those last times.
Okay, sure, no problem. So from next week, so you are going to take class at which time? You can tell me, so I will adjust at the time.
Okay.
So it's 12 or 1?
Uh, we can do 1 o'clock.
Okay, okay, sure. 1 o'clock every Saturday. Okay, all right. So do you have any question regarding your
Mhm.
previous lectures?
No.
Okay, so let's start our today's lecture. Today is our lecture number 19. Let me share my screen with you. Okay, so my screen is sharing with you.
Yeah.
Okay, so our today's lecture is about, we are going to discuss about pressure in detail. Then we will move on towards the temperature law. There are some important laws of temperature. The one important is Gay-Lussac's law. And then we will move on towards the fluid pressure and we will practice some practical problems regarding the fluid pressure as well as the temperature laws. So our learning objectives are we will state and explain and we will apply the Gay-Lussac's law, which states that pressure is directly proportional to the absolute temperature. This concept we already discussed in previous classes as well, but in today's lecture we will discuss in depth. And then we will move on towards to convert how we can convert temperature into Celsius as well as into Kelvins, the conversion, and then we will reinforce the pressure, which is liquid pressure, which is P is equal to rho g. This is the formula for liquid pressure, and we will solve some practical problems. And at last, we will apply all these data to solve some practical numericals as well. So let's start with the pressure. We already discussed about pressure in previous classes. So can you tell me a bit about what is pressure?
Um, like force.
Yes, pressure is basically a force. But which type of force? Because you know that always force is applied on some specific unit area. Definitely, okay. So pressure must be applied on some specific unit area. So if force is applied on some specific area, this concept is known as pressure. All right. So how you
Okay.
can define pressure? Pressure is the amount of force exerted per unit area on the surface. If you are applying more force, the pressure is more. And if you are applying less force, the pressure is less. How you know that? Because here you can see that the formula for pressure is P is equal to F divided by A, where P is have a direct relation with force and inverse relation with the area. If force increases, pressure increases. It means if you apply more force, it will exert more pressure, but it has an inverse relationship with area. It means if you decrease the surface area, the pressure exerts more. And if the area is large, the pressure is less. Okay. So there is an inverse relationship between pressure and area. Okay.
Yeah.
And also, we know that pressure can be measured in pascals because pascals is the SI unit of pressure, and force is that measured in newtons, and area, which is measured in meters square. So 1 pascal is equals to, because 1 pascal is the unit of pressure. How can you know 1 pascal is equals to? You have to put the SI unit for force, which is 1 Newton divided by area's which is meter square. So 1 Pascal is equals to 1 Newton per meter square. Okay.
Yeah.
If the same force is applied over a small area, the pressure increases, which I already tell you before that the pressure has an inverse relationship with the area. If area is smaller, so pressure definitely increases. Okay, and
Mm-hmm.
if the area is larger, so here you can see now the pressure decreases. Okay, so now we
Yeah.
have to discuss in different cases like pressure in solids, pressure in liquids, and pressure in gases. Whereas pressure in solids is concerned, pressure depends only on the area of contact. Same which I tell you before, like you know that the edges of knife is so sharp. Am I right?
Yeah.
If the edges of knife is so sharp, it means either the area is small or large.
Small.
Yes, the area is small. So if the area is small, so can you tell me it exerts more pressure or less pressure?
More pressure.
Yes, more pressure. So that's why you can cut different things easily with the help of a sharp knife, right?
Mm-hmm.
Hmm. Okay, and if the surface area is large, you are unable to cut because the area is large. And if the area is large, the pressure is small. And if the pressure is small, so force is small. And if the force is small, so you cannot cut the things easily. Whereas pressure in liquid is concerned, liquid pressure depends, pressure acts basically equally in all the direction at a given depth. It means if a liquid is poured in a cup of container, or you can say in a container, that liquid exerts pressure in all directions. All right. And we can also derive the formula for liquid and pressure in today's topic as well. Now move on towards pressure in gases. Pressure in gases also acts because you know that in gases consist of small particles, atoms, and molecules. And when those atoms or molecules vibrate with the walls of the container, they exert pressure. Those molecules which exerts pressure on the wall of the container, so this type of pressure is known as gas pressure. Okay, and gas pressure increases with the increase in temperature. If you increases the temperature, the gas pressure also increases. How? Because you know that when you increase the temperature, the kinetic energy of the particles increases. And if the kinetic energy increases, so now those particles vibrate more vigorously. So that's why pressure of gas increases. Any question?
No.
Okay, so here are some everyday examples like you see that car tires inflated. Why inflated? To increase the pressure of a proper grip of a tire on a road, as well as sharp tools like scissors and needles. Why those are so sharp? Because we want more pressure. That's why they are so sharp. If they are so sharp, it means their area is small, and if there is area small, the pressure it will exert more, the force it will exert more. Similarly, in hydraulic systems like car brake systems, car lift systems, we use liquid pressure systems. Liquid pressure, because we know that in liquid pressure it will exert pressure in all directions. That's why we can lift up things easily with the help of hydraulic systems. All right.
Right.
Hmm. Okay, so that's all about pressure. Now move on towards the Gay-Lussac law, which is an important law in physics. Gay-Lussac law basically tells us about the relationship between pressure and temperature at constant volume. What is the statement of a Gay-Lussac law? Here you can see for a fixed mass at a constant volume, the pressure is directly proportional to the temperature. What does it mean? It means if you increase the temperature, the pressure increases because there is a direct relationship between pressure and temperature. And if you decrease the temperature, the pressure decreases. The example I gave you before, like let's suppose you have a container and molecules inside, and when you increase the temperature of that container, the atoms of that container gain the kinetic energy, and if the kinetic energy increases, they vibrate now more vigorously. and they will strike with the wall of the container with more pressure. So by increasing the temperature, the pressure also increases. So this law explains by Gay-Lussac. And what's the formula for that? P divided by T equals to constant. Okay. Any question?
Nah.
Okay. So P1, T1, let's suppose P1 is the initial pressure and T1 is the initial temperature, whereas P2 is the final pressure and T2 is the final temperature. P2 and T2, when you increase the temperature, these are the initial pressure and temperatures, and these are the final pressure and temperatures when you increase the temperature. So here is a complete relationship. You have to keep remember this. We have to use this relationship in formulas. And here is the temperature conversion. You must have to use temperature in kelvins. You don't have to use temperature in Celsius or Fahrenheit. You must have to use the value of temperature in kelvins. And what is the conversion of kelvins is that just add 273 with the value of Celsius, you will get your kelvins value. Okay.
Yeah.
Initially, you have in degree Celsius temperature is given. What you have to do, just add 273. So you will convert it into kelvins. And already we discussed the graph between P versus T in previous lectures, and we see that the graph of P versus T is a straight line, if you remember those graphs.
Yeah.
Hmm. Okay, so now move on towards practical examples. A gas has a pressure of 150 kilopascals. So it means the pressure is given. And this is initial pressure or final pressure? Can you tell me?
Which one?
This is a gas has pressure 150 kilopascal. Is this initial pressure or final pressure?
Uh, Initial.
Yes, definitely initial. Good, because this pressure is at 300 kelvin. And he's asking to find the pressure at 450 kelvins. 450 kelvins is high temperature or 150 kelvins is a high temperature?
450.
Yes, 450. So it means temperature increases here at 450. So it means this is the final pressure which you have to find. It means you have to find the value of P2, and this pressure is the initial pressure which is P1. So data is P1 equals to 150 kilopascal. Initial temperature is given which is 300, and final temperature is also given which is T2 450 kelvins. So already the temperature value in Kelvin. So do we need any conversion here?
Nah.
Okay, we don't need any conversion, and we know what's the formula where we see the expression of pressure and temperature. We know P1 divided by T1 equals to P2 upon P3. So if you want to find P2, what you have to do, just multiply this to the other side. So your expression becomes P2 equals to P1 multiplied by T2 divided by T1. Just putting the values for P1, T2, and T1, you will get your answer, which is 225. If your initial pressure is in kilopascals, final pressure is also in,
Uh, Kilopascals.
yes, kilopascals, right. Second example, a sealed can gas has 100 kilopascals. Again, the initial pressure is given at 20 degrees Celsius. Again, the initial temperature is given heated to 60 degrees Celsius. Again, the final temperature is given. Find the new pressure. What you have to find, again, you have to find the P2. It means you have to use the same formula which we derived here. P2 equals to P1 T2 divided by T1. But here you can see, do we need any conversion of temperature here?
Mm,
Do we need any?
no.
Uh, can you check what's the unit of temperature here, Celsius?
Yeah.
So, as
Oh,
I
so we
mentioned you
do.
before, you must have to use the values of temperature in kelvins. So, you need conversion here. So, if the Celsius value is given, how can you convert it into kelvins? Can you tell me?
Um, Was it
Just add 273
add
this
to seven?
expression.
Mm-hmm.
So Celsius value plus 273, you will get your answer in Kelvins. All right.
Yeah.
So here you have to do same. 20 plus 273, it will becomes 293 kelvins, right? And 60 plus 273, it will becomes 333, right?
Mm-hmm. Yeah.
Now just put the values for P1, which is 100, T2, which is 333, and T1, which is 293. You will get your answer, which is approximately equals to 113.6 kilopascals. Any question?
Nah.
Okay. Now, third example, a tire is at 2 atm. What is atm? Basically, atm is the unit of pressure. It means atmospheric pressure, right?
Mm-hmm.
Pascals is also the unit of pressure, but atm is also one of the unit of pressure. What does this atm means? Atm means atmospheric pressure. Keep remember, okay? So initial pressure is again given, which is 2 atm. When air is at 15 degrees Celsius, again the initial temperature is given degrees Celsius. You have to find the final pressure and final temperature is given. Do we need any temperature conversion here?
Yeah.
Okay, so how can we do?
Add 273.
Yes, so 15 plus 273, it will becomes 288, and 45 plus 273, it will becomes 318. The formula is same which we here, because again you have to find the final pressure. The final pressure formula remains same, P1 T2 divided by T1. So P1, which is 2, T2, which is 318, and T1, which is 288. You will get your answer, which is 2.21, because here you can see your initial pressure is given in atm, so your final pressure you also in atm, not in pascals, right?
Yeah.
Hmm. So a gas in rigid cylinder has a pressure of 240 kilopascals. Initial pressure is given, which is 240 kilopascals. Initial temperature is given, which is 18 degrees Celsius. If the temperature rises to 78 degrees Celsius, now what you are going to increase the temperature at 70 degrees Celsius. Now you have to again find the new pressure. They're asking you to find again P2. The formula you know that P1, T2 divided by T1. But here you can see your temperatures are in Celsius. What you have to do, you have to convert it into kelvins. 18 plus 273, 291 kelvins. And 78 plus 273, you will get 351 kelvins. Now, just putting the values, you will get your answer approximately 289.3 kilopascals. All right.
Yeah.
Okay. So last problem. A steel tire reads 1.5 atm at 10 degrees Celsius. So can you tell me this pressure is initial or final?
Uh, initial.
And this temperature is initial or final?
Initial.
Yes. And after driving, the air warms. It means the temperature increases. And when the temperature increases, now this temperature is initial or final?
Final.
Final temperature. And what they're asking you to find?
New P2.
Yes, new pressure, which is P2. Again, you know the formula for P2, but before that, you have to convert Celsius into kelvins. Hmm?
Mm-hmm.
So here you did, and now just putting the values. Again, similarly, you will get your answer, which is 2.05 atm. Now, any question regarding these problems?
Nah.
Okay. So these all problems are related to pressure in solids. Now move on towards pressure in liquids. And what's the formula for pressure in liquids is different. P is equal to rho GH. This symbol represents rho, which is density, and this G represents the gravity, and this small h represents the height. Okay,
Mm-hmm.
here you can see P represents the pressure, which is measured in pascals, and you know that 1 Pascal is equal to Newton per meter square. Whereas rho, this symbol is rho, which means density of a liquid, and you know what is the unit of density. We can measure density in kilograms per meter cube. Whereas G is the gravitational field strength, and definitely we have to use on Earth, and the value for G on Earth is 9.8 meters per second square. Whereas H is the vertical depth of a liquid, and because H is height, and we know that height is measured in meters. Okay, and we know that liquid in pressure exerts pressure in all the directions. The important thing is that the deeper you go in a liquid, the greater the pressure. Okay, because there is more liquid above and adding more weight. As you go more deep into the liquid, let's take an example. You are going in a swimming pool. As you go more deep in a swimming pool, you will feel more pressure. Why is it so? Because you are increasing the height, you are decreasing the height. If you are decreasing the height, the pressure definitely increases. Okay, any question?
Mhm. Nah,
Okay, and as you move above, the pressure increases or decreases. As you
decreases,
move above the water.
decreases,
Yes, and if you move deep below the water, the pressure
increases.
increases. Why increases? Because there is more liquid above you, which adds more weight upon you. Okay.
Yeah.
Pressure also depends upon density as well. The height we already discussed that as you go more deeper, the pressure increases. As you go more above, the pressure decreases. And if you go more deeper, pressure increases. Pressure also depends upon gravity as well as pressure also depends upon rho. What is rho? As I mentioned you, rho is the density. And what is density? Density is basically how dense, how viscous your liquid is. So can you tell me which liquid is more viscous, either liquid or honey?
Honey,
Yes, honey. So whose density is more, liquid, water or honey?
honey.
Yes. So if you are in honey, let's suppose, so you will feel more pressure. Why more pressure? Because the density of honey is more. So pressure depends upon density as well as gravity, as well as height. You can see pressure increases if the density of liquid is higher. Pressure also increases as you go more deep. Pressure remains the same at the depth regardless of container shape. So it does not depend upon the shape of the container. It will only depends upon the depth, which is the height, the gravity, and the density of a liquid. Any question?
Nah.
And we already know that pressure in a liquid acts in all the directions. Okay, that is why dams are built thicker at the bottom. Why dams are built thicker at the bottom? Because at the
Um,
at the bottom of the dam, the pressure definitely is very high. And if the pressure is very high, there are chances that the dam may break off. That's why, to prevent, we are going to construct dams, their base, their bottom, very thicker, right?
mhm.
And also, the submarines and diving suits are designed to withstand high pressure because you know that the submarines and and divers, deep divers, have to go in very depth inside the water. That's why there are special suits designed to overcome the high pressure. Okay.
Hmm. Yeah.
Okay, now let's solve some practical problems regarding the liquid pressure. Let's suppose in water. Keep remember the density of water, which is 1000. Okay,
Mhm.
the density of water is constant and which is always 1000. And you know that what's the unit of density? Kilograms per meter cube. So here you can see, let's suppose if the water density is given and the depth is given, which is 5 meters. It means this is height and this is density. And they're asking you to find the pressure. The value of small g is not given, but you know that always the value of small g is 9.8.
Yeah.
So here we know that what's the formula? P is equals to rho gh. We have to just multiply all these three factors. So first factor is 1000 multiplied by g, which is 9.8, multiplied by height, which is depth 5 meters. You will get your answer, which is 49,000 pascals. And if you close it into prefix, because you know that three zeros close into kilo, because 1 kilo you know that equals to 10 power 3. So you can also write this 49 kilopascals. Am I right?
Yeah.
Okay. So if water pressure, again, now he says water pressure, but he don't give the density of water. So how can we remember? Do you know what's the density of water?
Yeah. 1,000
Yes, 1000. You
kilogram
have
per
to
meter
use
cubed.
yes. So you know the formula again, which is 5 meters given. You have 9.8 gravity and 1000. Again, same problem which we did here. Oil. Now oil. Definitely oil is more viscous. Let's suppose here the density of this oil is given, which is 850. The density here is less than water. And depth is given, which is 12 meters. So can you find the pressure of a liquid of this oil?
Yeah.
How can you find the pressure of this oil?
P equals rho G H.
Oh yes, rho gh. The value of rho is given, which is 850.
Mm-hmm.
Yes, the value of g, you know that 9.8 multiplies by height, which is depth. You will get your
Yeah.
answer, which is approximately 100 kilopascals.
Right.
Okay. Okay. So these are same problems which we already did. Initial temperature is given. Final temperature is initial temperature is given, but in Celsius, in Kelvins, it becomes 295. And again, the final temperature is given, and in Kelvins, it becomes 345. Initial pressure is given, and you have to find the final pressure. The same formula you have to use, which what we did in previous problems, right?
Yeah.
Okay. So can you tell me what is Gay-Lussac's law? What's their formula?
E1 over T1 equals to P2 over T2.
Yes, Gay-Lussac's law tells us the relationship between which two things?
Uh, Pressure and temperature.
Yes, and which thing remains constant?
Of, is it temperature?
No, because Gay-Lussac's law tells you the relationship between P and T. Uh, so what's other thing? P and T? Volume.
De yeah.
Yes. So volume must remains constant in Gay-Lussac's law. Okay, keep remember.
Okay.
And you have to use which temperatures, which unit, either Kelvins, Fahrenheit, or Celsius.
Kelvin.
Yes, Kelvins. And if the value is in Celsius, how can you convert Celsius into
Uh,
Kelvins?
Add 273.
Mm, yes, 270. Perfect. Uh, Here, let's suppose if the depth is 10 meters, if the
Uh-huh.
depth is 10 meters in water, so can you find the pressure of this
Yeah.
water? How can you find? Can you tell me? If the depth is 10 meters of a water, find the pressure of this water. How can you find?
1,000 times 9.8 times 10.
Yes, very good. Perfect. And you will get your answer, which is 98 kilopascals, right?
Yeah.
Okay, so these are some assessment questions for you. You can do practice at your home for your better explanation. Okay,
Hmm.
so here you can see the Gay-Lussac law and here liquid pressure final relationship. Okay, so now any
Yeah.
question regarding today's lecture you can ask.
Nah. Nah.
Okay, so if no, thanks for watching. We will meet again next week, the same time,
Okay.
1 p.m. Right?
Yeah. Yeah.
Oh, so
Okay.
so till then, take care and Allah Hafiz.
First, you too.
Thank you.